Dear viewers of Akshay.com, by Vetri from Pondicherry. So let me continue. The next, under the haloarenes and aryl halides, haloarenes or aryl halides, I am going to discuss preparation, properties and uses of chlorobenzene, which is included in our syllabus. So what we are seeing here, it is the structure of chlorobenzene. First, let me concentrate on preparation. Methods of preparation. What are the methods available to prepare the corresponding chlorobenzene? From benzene, I can prepare chlorobenzene. What is the method? Generally, aryl chlorides and aryl bromides are generally prepared from arenes by the action of chlorine or bromine in presence of a catalyst such as ferric chloride or ferric bromide. So suppose if I want chlorobenzene, I have to take benzene and I have to treat with the chlorine in presence of ferric chloride. The products will be chlorobenzene and HCl. So chlorobenzene can be prepared from benzene by the action of chlorine in presence of ferric chloride. This is the most important reaction that is coming under, that is halogenation. This is the most important reaction. Okay, let me go to the next one. Suppose if you want to get a bromobenzene, simple. So we have to take benzene, but instead of chlorine, we have to treat with the bromine in presence of ferric bromide. You will get corresponding bromobenzene and along with HBr. The one important information I want to record here: fluoro and iodo compound cannot be prepared by this method. Iodo compounds can be prepared with iodine in presence of nitric acid or iodic acid. This is the information I want to record here. Another most important method I can prepare chlorobenzene is from benzene diazonium chloride. This is a specific named reaction called Sand-Mayer reaction. Okay. Chlorobenzene can be prepared by the decomposition of benzene diazonium chloride in the presence of HCl or copper 1 chloride. So HCl plus of copper 1 chloride, the copper 1 chloride, I can prepare chlorobenzene. This is the stoichiometry. So diazonium chloride, CC35N double bond N Cl, diazonium chloride. So when you treat with the HCl process of copper 1 chloride, I can get chlorobenzene and nitrogen getting eliminated. This is the most important reaction called Sand-Mayer reaction. Can you follow? Sand-Mayer reaction is not useful for the preparation of fluorides and iodine. This is the most important information I want to record. So, Sand-Mayer reaction is applicable only for chlorobenzene and bromobenzene, but not for iodobenzene or fluorobenzene. This is the point I want to stress here. Next one, industrial method. So, I can prepare large scale chlorobenzene. What is the method here? Again, chlorobenzene is produced industrially by passing a mixture of benzene vapor, air and the hydrogen chloride over a copper 1 chloride catalyst. This is called a Raschig process, R-A-S-C-H-I, Raschig process. Again, starting material is benzene, but I am treated with HCl in presence of copper chloride, that is because of air, I am getting chlorobenzene and water. This is the industrial method, large scale. So, by using any one of these methods, I can prepare chlorobenzene. So next, let me discuss the properties. Under the physical properties, let me do some information. Chlorobenzene is a colorless, pleasant smelling liquid. It is a colorless, pleasant smelling liquid. And also, it is insoluble in water. This is the most important physical property. So let me discuss chemical property. The chlorobenzene has an aromatic ring and the chlorine atom directly bonded to the ring. So, I can discuss a reaction due to aromatic ring and reaction due to chlorine atom I will discuss. So, that means here, so number one, the reactions involving aromatic ring, another is reaction involving halogen atom. I can discuss the chemical properties. First, let me take reactions involving the aromatic ring. So under this, the most important aromatic electrophilic substitution reactions. This is the most important. So just I will give some introduction here. What is electrophilic substitution? What is nucleophilic substitution? And what it is important for aromatic? Here I want to give a general statement. Generally, aromatic compound will undergo electrophilic substitution, whereas aliphatic compound will undergo nucleophilic substitution. You can raise a question, why it is so? The reason I can explain as follows. That in the case of aromatic ring, there is a benzene ring. Benzene ring means we know there are 3 double bonds, that is 6 pi electrons. So the electrons are nothing but negatively charged. So when electrophiles are approaching the benzene ring, they can easily attack the corresponding negative. That's why aromatic electrophilic substitution is most important rather than nucleophilic substitution. But under a transitive condition, even that is nucleophilic reaction substitution can take place in the case of aromatic, but under the special condition. So here, let me discuss aromatic electrophilic substitution reactions. Chlorobenzene undergoes the typical aromatic electrophilic substitution reaction like 1. Alkylation or acylation, 2. Halogenation, 3. Nitration, 4. Sulfuration, etc. So these are the commonly we are studying under the aromatic electrophilic substitution reaction. So this I will discuss under the chlorobenzene. First one, alkylation. This is also known as Friedel-Graf alkylation. I can call it as Friedel-Graf alkylation. So chlorobenzene can follow in the case of methyl chloride. What will happen now? The corresponding the anhydrous aluminum chloride. Now what I can do is that is I am getting orthochlorotoluene and parachlorotoluene. This is the most important reaction. The reason here it is chlorine is an electron releasing group, ortho-para orienting. So when we are treating with methyl chloride, so methyl plus is going to attack. So it will attack ortho and para. That's why a mixture of 2 products. This is the called alkylation. The corresponding next one, acylation. Suppose under this, instead of methyl chloride here, acetyl chloride reacts with the chlorobenzene in presence of anhydrous aluminum chloride. Again, a mixture of 2 products. That means that is the orthochloroacetophenone, parachloroacetophenone will be formed. 2 products. This is the coming under the acylation. Coming for chlorination. That is, chlorobenzene reacts with the chlorine in presence of ion to produce ortho dichlorobenzene, para-dichlorobenzene product. 1,2 dichlorobenzene, 1,4 dichlorobenzene. So this is the another interesting reaction under the chlorination. Coming for nitration. Under the nitration, chlorobenzene reacts with the concentrated nitric acid and the concentrated sulfuric acid to produce mixture of again ortho and para-nitro. So in this case, orthochloronitrobenzene and parachloronitrobenzene. So 2 products will form always. Finally, coming for sulfonation, again chlorobenzene reacts with the concentrated sulfuric acid to produce orthochlorobenzene sulfonic acid and parachlorobenzene sulfonic acid. Again, a mixture of products. In all the cases, I have already explained why we are getting a mixture of ortho and para, because chlorine is the electron releasing group, nothing but ortho-para orienting group. So that's why in all the reactions that I have discussed here, a mixture of ortho and para product is. This is the most important information I want to know. Another most important reaction is formation of DDT. That is para dichloro diphenyl trichloroethane. This is called DDT. So in this case, chloral CCl3CHO reacts with 2 molecules of chlorobenzene in presence of sulfuric acid. We are getting the DDT. The DDT nothing but kindly follow, there are 2 benzene in para position chlorine. So in that case, para dichloro diphenyl trichloroethane. This is the product, nothing but DDT. This is another interesting product coming under this chlorobenzene. So far what I have discussed, the reaction involving aromatic ring. The next let me go for the reactions involved with the halogen atom. Under this, I can say nucleophilic aromatic substitution. This is the most important. Due to the tendency of the halogen atom to share its lone pair of the electron with the benzene ring, it acquires some double bond character. This is the most important. So, due to the tendency of the halogen atom to share its lone pair of electron with the benzene ring where it is present, it acquires some double bond character. What happens because it hints nucleophilic substitution of chlorine atom can take place under vigorous condition. What will be vigorous condition? Very high temperature, very high pressure is required to involve this reaction. Let me discuss the conditions. First one, formation of benzene, that is called a reduction. Under this, when treated with nickel aluminum alloy in the presence of sodium hydroxide, chlorobenzene undergoes reduction to produce benzene. So in this case, chlorobenzene, chlorine will be substituted by the chlorine is removed from this, so we are getting the benzene. So nickel aluminum sodium hydroxide undergoes reduction to give benzene and SC. Okay, the next one. Next one, formation of ethyl benzene. This is called Wurtz-Fittig reaction. This is one of the most important name reaction. What is Wurtz-Fittig reaction? Chlorobenzene on reaction with sodium and ethyl chloride in presence of ether produces ethyl benzene. Can you follow? Chlorobenzene, 2 moles of sodium and ethyl chloride in presence of dry ether produces ethyl benzene. Ethyl benzene is nothing but alkyl. This is ethyl benzene. This is alkyl, that is the other alkyl, we will call it as a carbon, so along with 2 moles of sodium chloride. So ethyl benzene, so this is the most important, this name reaction is called Wurtz-Fittig reaction. Can you follow? You must know the difference between Wurtz and Wurtz-Fittig. Wurtz means both sides aliphatic. So RR. Wurtz-Fittig means one side CCH5, other side is the alkyl part, that is called Wurtz-Fittig. There is one more reaction fitting, both sides phenyl group. So that also we will discuss that. So this is the latest information. So in Wurtz-Fittig reaction, chlorobenzene reacts with 2 moles of sodium and the ethyl chloride in presence of dry ether, they produce the ethyl benzene. Okay, let me go next one. Formation of biphenyl. This is Fittig reaction. Just now I informed you. Fittig reaction again involving the chlorine atom. 2 moles of chlorobenzene in ether solution react with the sodium to give biphenyl. For example, chlorobenzene 2 moles reacts with the 2 moles of sodium in presence of dry ether. I am getting biphenyl. So this is the famous reaction called Fittig reaction. So can you follow? So under this we are having 3: Wurtz-Fittig and Fittig reaction. This is the most important reaction. Next one. Formation of phenol reagent. Chlorobenzene on reacts with magnesium in presence of tetrahydrophenol, that is called THF, to produce phenyl magnesium chloride, that is called phenol reagent. So as in the case of ordinary aliphatic side RMgX, so the R here, if it is a phenyl ring, it is called, we can use the chlorobenzene. So in this case, chlorobenzene reacts with the magnesium in presence of tetrahydrophenol. We are getting now that is phenyl magnesium chloride, nothing but phenol reagent. This is the most important again reaction under this chlorobenzene. The next one, formation of phenol, is called the Dawes process. Chlorobenzene reacts with the sodium hydroxide at a high temperature and high pressure to produce phenol. This is the condition I already explained. It's a nucleophilic substitution reaction. Can you follow? Cl is substituted by OH minus. What is the condition? 623 Kelvin, 300 atmosphere. Very high temperature, very high pressure. So we are getting phenol and along with sodium chloride. So chlorobenzene reacts with sodium hydroxide at the high temperature, in this case 623 Kelvin, high pressure 300 atmosphere to produce phenol. This is the most important nucleophilic substitution reaction. Another one is again formation of aniline. Again, the another important reaction, nucleophilic substitution reaction. Chlorobenzene reacts with ammonia at a high temperature and a high pressure to produce aniline and ammonium chloride. As I have already pointed, this is another most important nucleophilic substitution reaction. So in this case, chlorobenzene reacts with 2 moles of ammonia at high temperature 520 degree Kelvin, high pressure 50 atmosphere to produce aniline and ammonium chloride. This is called aniline can be prepared from chlorine. The next other most important reaction is formation of phenyl cyanide. That is, Cl will be substituted by Cl minus. That is, Cl minus will be substituted by Cl minus. Can you follow? Chlorobenzene reacts with the copper cyanide at a high temperature and high pressure to produce phenyl cyanide and copper 1. So, chlorobenzene again reacts with the copper cyanide, the copper 1 cyanide at 520 degree Kelvin in presence of pyridine. We are getting phenyl cyanide and copper. This is the very interesting information. Next, coming for uses, the most important, chlorobenzene. It is used 1 for the manufacture of many compounds like phenol, nitrobenzene, etc., which are required for the manufacture of azo and sulfur. And also, it is also used for the preparation of insecticide like DDT and BHC. BHC, benzene hexachloride. One of the isomer is Gunasegaran. So this is the most important information regarding aromatic strategy chlorobenzene. Next, let me discuss the most important, another most important under the highlights is Grignard reagent. So let me discuss the preparation properties of Grignard reagent. Normally, question can be asked from this. So Grignard reagent, another most important, is having a very important applications. We can prepare any compound from the help of Grignard reagent. That's why this is the preparation properties of Grignard reagent is most important. Organomagnesium halides are called Grignard reagent. Very fast. Organomagnesium halides are called Grignard reagent. They are generally represented by RMGs. Specific example I am going to use here, methyl magnesium iodide, or sometimes you can use ethyl magnesium iodide. In the case of aromatic, phenyl magnesium iodide. How will you prepare? How to prepare Grignard reagent? Preparation. Methyl magnesium iodide can be prepared by the action of methyl iodide on magnesium suspended in dry ether. All the reagents should be pure and dry. The other most important, it will be always present in this solution. That is the most important information. So, whenever you are getting Grignard reagent from any company, they will supply in the form of ether solution only. It will not be like solid like ether solution. So, we have to use. Now, let me discuss the preparation. When the reaction is completed, a clear solution of methyl magnesium iodide is obtained. Clear solution. This is used as such in all the reactions. Only the clear solution we are using as a Grignard reagent. So this is the stoichiometry. Methyl iodide, magnesium in presence of dry ether, methyl magnesium iodide. So it is present in dry ether, means it will be in the form of a ether solution. So that solution only we are going to use as a Grignard reagent. Very interesting. Let me come for the synthetic applications or synthetic uses of methyl magnesium iodide. Methyl magnesium iodide can be used to synthesize a number of variety of organic compounds as follows. Any compound you can synthesize almost from the using of Grignard reagent. But then let me give one by one. So, 1. Alkanes can be prepared, alcohols can be prepared, ethers can be prepared, aldehydes can be prepared. This continues. Ketones can be prepared, carboxylic acids can be prepared, carboxylic esters can be prepared, and cyanides also can be prepared. Most of the organic compound can be synthesized from using suitable Grignard reagent. So any suitable compound can be prepared by using suitable Grignard reagent. So let me discuss one by one. First one, preparation of alkanes. So alkanes can be prepared using a Grignard reagent, that is CH3MgI. So let me take one. Methyl magnesium iodide undergoes the double decomposition with water and alcohol to produce alkanes. That is, methyl magnesium iodide undergoes double decomposition with water and alcohol to produce alkane. So, for example, methyl magnesium iodide, water. So, what happens? You are taking water. So, this methyl magnesium iodide taking this wire, the corresponding methane is produced, and we are getting MgOHI. Right. So, now the same way, the methyl magnesium iodide is treated with methanol. So, we are getting methane and MgOCH3I. The interesting information again as usual. So we are getting this. So we are getting again methane. So by using water or by using any alcohol, we can prepare corresponding alkane. Suppose I want methane, I can use methyl magnesium iodide. Suppose I want ether, I will use ethyl magnesium iodide. Suppose I want to prepare benzene, phenyl magnesium iodide, I can use. So any alkane or aromatic reactor carbon I can prepare with the help of trigonometry. Next, let me go to the second most important application is preparation of primary alcohol. Under the alcohol, so primary alcohols. So methyl magnesium iodide undergoes additional reaction with formaldehyde to give additional product, which on hydrolysis yield ethanol or primary alcohol. So this is the most important. So let me give a general idea. Kindly follow, students. Any alcohol you can prepare using a Grignard reagent, but if you want to get primary alcohol, use formaldehyde. If you want secondary alcohol, any aldehyde other than formaldehyde. But if you want a tertiary alcohol, we have to use ketone. This is the idea. So depending upon the nature, we have to select suitable Grignard reagent. So let me give a physical example. So I want to prepare ethyl alcohol. So I am using CH3 MgI, methyl magnesium iodide, and formaldehyde. So what will happen now? Here, this is the way it leaves. So when it is cleaved now, so methyl group is added here and OMgI added here in this. So this is called an intermediate. So this product intermediate now what will happen? Undergoes hydrolysis with the presence of acid medium. So we are getting the corresponding product. That is, so this intermediate, when it is treated with water in presence of an acid medium, so we are getting ethanol and MgOHI we are getting. So how it is cleaved now? Here HOH, this is the way it is cleaved. So we are getting a primary. So if I use that is methyl magnesium iodide, I will get corresponding ethyl alcohol. If I use ethyl magnesium iodide, I will get the propyl alcohol. Like this one number higher, we can get. This is the interesting information. So primary alcohol I can get from by using formaldehyde. Suppose if I want to get the secondary alcohol, so let me explain how we have to use. I have already pointed out any aldehyde other than formaldehyde I have to use. So methyl magnesium iodide undergoes additional reaction with acetaldehyde to give additional product, which on under hydrolysis yield isopropyl alcohol or secondary alcohol in this case. So for example, methyl magnesium iodide acetaldehyde as usual. Now this will be plus, this will be minus. So he can cleave now. So by adding, this is the intermediate is formed. So what happens now? This intermediate undergo hydrolysis at water with an acid. So again getting cleaved. So we are getting this corresponding secondary alcohol, nothing but isopropyl alcohol along with the MgOHI. So this 2-propanol we are getting with the help of acetaldehyde. This is the interesting information. Coming for preparation of tertiary alcohol. So tertiary alcohol if I want, I have to use a ketone. Just reason methyl magnesium iodide undergoes additional reaction with acetone to give additional product, which on hydrolysis yield tertiary alcohol, that is tertiary butyl alcohol here. So methyl magnesium iodide, here it is corresponding acetone. As usual, it is getting cleared like this. So I am getting this intermediate. So this intermediate undergoes hydrolysis to produce again this product. This is nothing but tertiary butyl alcohol, correspondingly MgOHI. So this is the interesting information. So this is the tertiary alcohol. So let me recollect again. So any alcohol we can prepare with the help of Grignard reagent. So if you want to primary alcohol, use formaldehyde. If you want secondary alcohol, use any aldehyde other than formaldehyde. If you want tertiary alcohol, use a ketone. This is the interesting information I want to record here. The next one, preparation of ether. So ether can be prepared using Grignard reagent. Just see here what way. Methyl magnesium iodide undergoes double decomposition with methoxymethyl iodide to produce ethyl methyl ether, a higher ether. So here, in this case, so methyl magnesium iodide, we are treating with correspondingly, that is methoxymethyl iodide. So to produce correspondingly, that is 1-methoxyethane or methyl, that is ethyl methyl ether and MgI2. This is the interesting information I want to record. Next, another important method, preparation of aldehyde. So whenever I want to get aldehyde, so this is the method I have to follow. So I have to use always format I have to, ethyl format or methyl format I have to follow. So, methyl magnesium iodide undergoes addition reaction with ethyl format to give addition product which on hydrolysis yield acetaldehyde and aldehyde. This is very interesting. So, for example here, this methyl magnesium iodide undergoes addition reaction with this for ethyl format. So, I am getting this intermediate. So, this intermediate again hydrolysis synthesis of acid intermediate. So, what will happen now correspondingly? This is getting cleaved like this. So, you are getting now acetaldehyde corresponding MgO(C2H5) it is product. So, product is acetaldehyde. So, whenever you want to get acetaldehyde as a product, the corresponding format I have used. Any aldehyde I have used format depending upon your use suitable aldehyde. The next one, preparation of ketones. Any ketone I can prepare. So, in this case I will show you how I am getting the corresponding the acetone. So, methyl magnesium iodide undergoes addition reaction with acetyl chloride to give addition product which on hydrolysis yield acetone, a ketone. See here, methyl magnesium iodide. So, this is acetyl chloride cleaved like this. So, I am getting this product. Simple intermediate. So, this intermediate undergoes the hydrolysis to produce the corresponding acetone. That is this way it is undergoing. Clear? So, I am getting acetone, then MgCl(I) it is. So, this is the interesting information regarding the ketone. So, acetone I can prepare. So, kindly follow. So, we are adding methyl magnesium iodide getting acetone. So, depending upon the nature of ketone, you have to change the corresponding acid chloride you can change, or you can change the pregnant reagent you can change. So, any ketone can be prepared. Next one, preparation of carboxylic acid, another most important preparations. So, methyl magnesium iodide undergoes addition reaction with carbon dioxide to give addition product which on hydrolysis yield acetic acid. Say for example here, methyl magnesium iodide will cleave like this. So, now what will happen now? This will undergo cleavage again. So, you are getting this intermediate. So, this intermediate undergoes hydrolysis. So, this intermediate undergoes hydrolysis with acid medium gives acetic acid and MgOH. So, if you want to get the acetic acid, so I will use methyl magnesium iodide and carbon dioxide. If I want propionic acid, I will use ethyl magnesium iodide. If I want benzoic acid, I will use phenyl magnesium iodide. So, depending upon the nature of acid required, I will simply change the Grignard reagent. I can get any acid. So, any acid can be prepared using Grignard reagent. The next one, preparation of ester. Another, I can prepare ester from Grignard reagent. But wait, methyl magnesium iodide undergoes addition reaction with ethyl chloroformate to give addition product which on hydrolysis yield ethyl acetate and ester. Can you look at the starting material? So, methyl magnesium iodide reacts with, this is called ethyl chloroformate. So, what way it will cleave now? Can you follow? This is the way it will cleave. So, I am getting the intermediate form. This intermediate undergo this hydrolysis. So, produce now ethyl acetate and MgCl(I) it is formed. So, this is the interesting information. So, any that is here, ethyl acetate is nothing but an ester. So, I can prepare any ester by using suitable Grignard reagent. So, that is the finally, let me discuss preparation of cyanide. Any cyanide I can prepare. Under this, methyl magnesium iodide undergoes double decomposition with the cyanogen chloride to produce methyl cyanide. So, here what is the starting material? Methyl magnesium iodide, CnCl to produce methyl cyanide and magnesium, that is MgCl(I). So, what way it will cleave now? It will cleave like this correspondingly. So, we can think of lines. So, I can now get like this. So, methyl magnesium iodide reacts with cyanogen chloride to produce methyl cyanide and MgCl(I). So, any alkyl cyanide I can prepare using the Grignard reagent. Suppose if I use methyl magnesium iodide, I can get methyl cyanide. If I use ethyl magnesium iodide, I can get ethyl cyanide. If I get phenyl magnesium iodide, I can get phenyl cyanide. So, any cyanide I can prepare with the help of Grignard reagent. So, this is the most important reaction. I hope you have enjoyed the lecture. Thank you.